Hello everyone, and welcome back to my third video in my three-part series, LLMs and Distributed Cloud Computing. Now today I have something super special to share with you, a functioning LLM. How, you may ask? I had nothing to do with it. This is Amazon Bedrock we're going to be using, and we're going to be invoking it via a Lambda function invoked by gRPC. How is that possible, Dylan? Are you stupid? gRPC requires a server, and by definition, Lambda is serverless. Great point. We are going to be invoking it with a RESTful proxy of gRPC, wherein we send a base64 encoded protobuf object and then decode it over at Lambda. And then we're going to create another protobuf object and then encode it and back into base64 and send it back. We'll get into the specifics on what that looks like and how we do it in just a moment. But for right now, I think we should start with a demo. Oh, whoops. So first, let's log into our EC2 here, where we have our Akka server. This is what's going to relay our messages to the Lambda as protobuf. So let's run that. Our arguments. The arguments are going to be, we're going to use the main server, because I also have a test server on here for using actual gRPC. And the endpoint. So let's get that Amazon API Gateway endpoint. There we go. All right, and that's it. That is all we need to get started. And we're ready to start sending it messages. So I think what I'd like to do is, I want to, not localhost anymore. I want to just curl the server and ask it, who am I talking to see which AI model that we're going to be chatting with. So what is our IP address? There we go. We have it open on port 8080. And the path to communicate with it is chat. It doesn't say it on there, but that is the path we're going to be using. Got to make sure it knows that we're using, we're going to be using JSON to send the message, or to package the message. Application / JSON. And all we got to do now is just send that payload. It's going to be an input and our message. Who am I speaking to? And I think that's it. Let's give it a try. Oh, whoops. There we go. All right, so it turns out we are talking to Coral, built by Cohere. So there you go. In fact, let me show the logs so that you can see that we're not just, our Akka server isn't the one actually doing any of the Bedrock invocations. We'll view the CloudWatch logs here. There we go. Input. So you might notice here, like, that's not what I typed. That is the protobuf, the base64 encoded protobuf input message, which we then decode in Lambda because they both share the same protobuf file. I will show you that in a moment. We then talk to Bedrock. We get a response. There it is. We're going to package that back up as another base64 encoded message and send it back. All right, so I think we're ready to see the specifics. How do we do that? So over here on the left-hand side, we have our lambda.proto. This is where we specify our input message, our output message objects. And then we also have the RPC right here. Now, again, because we don't have an actual server running, we can't invoke this directly. We're going to be doing a RESTful proxy of that. We'll get into that in a moment. So here's the Akka server on the left here. We still set up our gRPC client as if we would normally, and we're going to be just forwarding requests. That's all we're going to be doing. We're going to take the input message and we're just going to forward it. We're going to send it to the client. So what does that look like? So normally, I'll go to the bottom here. Normally this is what it would look like. We set up our input message request and we're going to invoke the Lambda function, and some server is going to see, I've been invoked. It's going to turn it into an output message and it's going to send it back. Now we can't do that. Lambda doesn't have a server that it's running on by default. So what we do is we're going to still set up an input message, but we're going to serialize it. We're going to base64 encode it, and we are going to send it via regular HTTP post request. What Lambda is going to do is it's going to receive that request. It's going to decode the base64 message and turn it back into an input message from those decoded bytes. With that message, we are then able to communicate with Lambda, where afterwards we will take that Lambda response. We are going to create an output message with it. As you can see over here, that's the other object. And then base64 encode that message and send it over as a response. Our client will then pick that up, and it's going to do the opposite. It's going to decode that message, turn it back into an output message, and it's going to return that output message. Obviously, this is a lot of steps that we really don't need to do to just, to just forward a message along. But if hypothetically, if you had very complex objects and you wanted to make sure on the front and the back end both that the same objects were being used, this is a good way to do it, since by default REST doesn't require the front end to know anything at all about the back end. On a successful message, we're just going to return whatever the bedrock response was back to the user, which is what you saw right over here. And that's it. There's really not much more to it. Is there any actual benefit, purpose to this? Not really, besides what I said, where you get to share the same objects on both the front end and the back end. There's that benefit, but you don't get any of the speed, or you don't get the streams that generally come with gRPC. It's definitely not fast, because we have to go through the middleman, and then we have to spend a couple extra steps encoding the message and then sending it, rather than just forwarding it along, which it's already expecting to read regular human readable text. There's really no need to serialize it. But I guess I could see if you have very complex objects that you're sending over HTTP, then this is a way of strictly enforcing that those objects are sent correctly. Anyway, I hope you enjoyed this video. I definitely enjoyed this project, as I actually felt like I did something, rather than these past projects where I don't have billions of dollars to make a real LLM with, so couldn't really see the actual success. I couldn't really feel the victory of making a real LLM, because I can't. Anyway, yep, that's it. So I hope you enjoyed the video. Have a good one.